Engineers did the math, and the answer was terrifying. If you poured the Hoover Dam the way you'd pour a sidewalk, all at once, the concrete inside would still be cooling 125 years later, and long before then, it would tear itself apart. Not from the weight of the water, not from an earthquake, from its own heat. The Hoover Dam should have been impossible to build. So how is it still standing, almost a century later? To understand the problem, you have to stand where they started. Black Canyon, on the Colorado River, right on the border of Nevada and Arizona. A narrow gap of black rock with a wild river tearing through the bottom of it. It was the middle of the Great Depression. Thousands of desperate men drove into the desert looking for work, sleeping in tents in heat that could pass 120 degrees. The government even built a whole town, Boulder City, just to house them. But before anyone could pour a single bucket of concrete, they had a bigger problem. You cannot build a dam in a river that is still flowing. So the first job wasn't building, it was making a river disappear. Their answer was brute force on an unimaginable scale. They bored 4 enormous tunnels straight through the solid walls of the canyon, each one 56 feet across, wide enough to swallow a 4-lane highway. Then they forced the entire Colorado River through them, around the work site. With the canyon floor finally dry, the real construction began, and it was the largest concrete structure humanity had ever attempted. Over 3 million cubic yards of it, enough to build a road stretching clear across the country. But that mountain of concrete hid a secret enemy. Here's what almost nobody realizes about concrete. It doesn't dry, it cures. When cement and water mix, they trigger a chemical reaction, and that reaction gives off heat. In a thin sidewalk, the heat escapes into the air, and you never notice it. But the Hoover Dam is not thin. At its base, it is more than 600 feet thick, a solid wall of rock-hard concrete taller than a skyscraper laid on its side. Deep in the center of that mass, the heat would have nowhere to go. So the engineers ran the numbers, and that's where they got the nightmare figure. Poured as one giant block, the core of the dam would trap so much heat that it would take 125 years to cool down to the temperature of the canyon around it. And a cooling object shrinks. As the outside cooled and the inside stayed hot, the concrete would pull against itself with enormous force. It would crack, it would crumble. A finished dam, holding back the largest reservoir in America, quietly destroying itself from the inside out. So what do? The first idea was elegant. Don't pour one giant block at all. Instead, build the dam out of hundreds of separate columns, interlocking towers of concrete, each one poured in thin layers, just 5 feet deep at a time. Smaller pieces mean less trapped heat, and more surface for that heat to escape. But even that wasn't enough. The columns were still cooling far too slowly. They needed to reach inside the concrete and pull the heat out actively. They needed to refrigerate the dam, and that is exactly what they did. As each 5-foot layer was poured, workers laid down a grid of thin steel pipe inside it, 1 inch across, looping back and forth through the wet concrete. When you add it all up, they buried around 582 miles of pipe inside the Hoover Dam. Then they pumped water through it. At first, cold water straight from the river, carrying the worst of the heat away. But to finish the job, they built a refrigeration plant right there on the site. An ice factory capable of producing 1,000 tons of ice every single day. Chilled water from that plant flowed through the hidden pipes, drawing the last of the heat out of the concrete from the inside. They were, quite literally, freezing the dam solid on a schedule. A job that nature would have taken a century and a quarter to do was finished in under 2 years. By March of 1935, the artificial cooling was complete. But now, the dam was full of hundreds of separate columns with thin gaps between them. So the crews pumped a cement grout into every joint, gluing the towers into one seamless, monolithic wall of concrete. Only then was it truly a single dam. None of this came cheap, and I don't just mean money. Building in that heat, dangling from cliffs, blasting tunnels through rock, it killed people. 96 workers died in industrial accidents during construction. Every foot of that dam was earned. But when it was done, they had built something that still stuns engineers today. A wall of concrete 726 feet high. And it doesn't hold the water back by brute strength alone. It's curved, The arch shape pushes the immense pressure of the reservoir sideways into the solid walls of the canyon itself. The rock helps hold the river. Behind it rose Lake Mead, the largest reservoir in the United States, stretching more than 100 miles up the canyon. And inside the dam, 17 giant turbines began to spin, turning the weight of falling water into more than 2,000 megawatts of electricity, power for millions of homes. Think about what that generation actually pulled off. In the middle of the worst economic collapse in modern history, with slide rules and hand calculations, they identified a problem invisible to the naked eye: heat, buried in stone. And they solved it by inventing a way to air-condition a mountain of concrete. The Hoover Dam should have cracked itself apart. It should have taken 125 years just to cool. Instead, it became one of the most reliable structures ever built, because a group of engineers refused to accept that impossible was the final answer. But Hoover isn't even the most extreme dam ever attempted. Somewhere out there, engineers built a dam so massive it slightly changed the speed of the Earth's rotation. That's the next story. We'll see you there.